Welcome to 5.6. We're going to be looking at equations with decimals. Basically, we're going to be putting together everything we know about equations with everything we know about decimals. So let's jump right in. Let's solve an equation. So here we go. X minus 3.5 equals 8.7. So what we can do here is we can solve this the way we would typically solve it. Look for what's being done to x. In this case, 3.5 is being subtracted. So let's add 3.5 to both sides. And over here, it'll zero out. We'll isolate the x. And over here, we will get our solution. And then, of course, how can we check to see if this is right? We can take it and we can plug it in, just like we've always been able to, back into our original equation and see if it satisfies the equation. 12.2 minus 3.5 is 8.7, so it checks out. All right, here's the next one. 4y equals negative 3.32. So if 4y equals this, then to find out what 1y is, I need to divide both sides by 4. So 4 divided by 4 is 1y equals a negative divided by a positive is a negative. Now I'll come over here and I'll do the math. Four won't go into 3, but it will go into 33 8 times. So it goes in evenly. So negative 0.83. And it makes sense that it would be less than 1, because if 4y was 3 and a bit, then 1y would have to be less than 1. All right, how about something a little bit more involved? Okay, so the first thing we want to do is we want to get all the variable terms to one side. So in this case, I see here's this variable term here and one here, and I typically want to go after the smaller one. In this case, negative 5 is smaller than 7. So I'll go after this one by zeroing it out. If I add 5a to this side, I have to add 5a to this side. Negative 5a plus 5a, that zeroes out. So that's exactly what I wanted. Now that I have my variable terms together, I can get my constant terms together. Take 61 hundredths away from both sides. So here those zero out. So I have 12a equals negative 89 hundredths minus 61 hundredths more. I'm really actually adding and going more negative. So it's going to be, let's see, it's going to be a 0, carry the 1, 14, 15, carry the 1, so 1.50. Okay, now we're not done yet. So all I found out is that 12a equals negative 1.5. So I need to find out what 1a is. So I'm going to divide both sides by 12. Over here I get 1a, and over here it'll produce a negative, but what exactly will it be? It won't go into 1, but it will go into 15. It will go into 32 times. And it'll go into 65 times. Evenly. So there's no more zeros to bring down if it goes in evenly like that. I can say I'm done, and I don't really have a remainder. And of course, I can take this answer and I can plug it back into my original equation to check it. All right, so let's talk about problem solving. This is the same blueprint that we talked about the last time we talked about problem solving. So we're going to kind of go through some problems and see if we can piece together a solution. So a rental car company charges $11 per day and 16 cents per mile for their cars. If a car was rented for 1 day and the charge was $25.40, how many miles was the car driven? Interesting. Okay. So here are some things that we know. We know they charge $11 per day plus 16 cents per mile. We know this is a 1-day rental. We know the total was $25.40. So we want to know how many miles the car was driven. So here are some things we know. We know that $11 per day times 1 day, that would get us how much it costs for the initial daily rental, plus 16 cents per mile times how many miles we don't know, totals my total rental cost. So this is the number of miles, and this is the number of days in my formula here. So I have cost per day, cost per mile. All I have to do is plug in my number of days, my number of miles. In this case, I know the number of days. I don't know the number of miles, but I do know the total cost. So now I can solve. So I'll simplify, isolate my variable, and I'll know how many miles I drove. So 11 times 1 is 11. So it's $11 for the day. So if I take away 11 from both sides, I find out that it was $14.40 in mileage charges. And if I divide both sides by 16 cents, I'll find out that X equals how many miles I drove. And in this case, it's 90. So 90 miles. Now, does this make sense? Does this seem reasonable? Yeah, if you could drive 75 miles an hour on the highway, then driving 90 miles in a day with a rental car seems definitely reasonable. So hopefully that made sense as a real-world scenario that you could solve using decimals and your knowledge of solving equations. Let's look at one more that's a little bit more abstract. So Diane has $1.60 in dimes and nickels. If she has 7 more dimes than nickels, how many of each coin does she have? Okay, this one may not seem as intuitive. So she has $1.60. And she has 7 more dimes than nickels. So let's see. 7 more dimes than nickels. So we can make a little chart here. I do like this little chart. So the number, they have the number of and the value of let's see, nickels, dimes. So nickels are 5 cents each. So the value is 5 cents times however many nickels we have. Well, how many nickels do we have? The number of nickels is unknown. Well, the number of dimes is unknown as well, except that we do know dimes in terms of nickels. We know that there's 7 more dimes than nickels. So however many nickels there are, if you take that number and add 7, that would tell you how many dimes there were. Now, the value of a nickel is 5 cents. So the value of all the nickels is 5 cents times the number of nickels. The value of a dime is 10 cents. So the total value of all the dimes is 10 cents times the total number of dimes you have. So there's an expression that shows you the value of all the nickels. There's an expression that shows you the value of all the dimes. And you know that if you add them together and equal them to the total, then you can find out how many nickels and dimes you need. So now in this case, one of the easiest ways to solve a problem involving decimals is actually to multiply to get rid of the decimal. But we're not going to do that here. We're just going to go ahead and work with the decimals because we can. We're not afraid of them. We don't mind working with decimals. Now when I distribute here, I get rid of those parentheses and I can combine some like terms. Now I can isolate my variable term by subtracting this 0.70 by getting rid of whatever is not my variable term. And then I can divide both sides by my coefficient here to find out that x is 6. Okay, so x is 6. Did that answer my question? Maybe, maybe not. So my actual question was about dimes and nickels. So let me go back up to my chart here. So what was x? X was the number of nickels. Okay, so the number of nickels, there's 6 nickels. So how many dimes are there? Well, if there's 6 nickels, there's 7 more dimes than nickels. So that means there's 13 dimes. So 6 nickels and 13 dimes. And that makes sense because 13 dimes would have a value of $1.30. 6 nickels would have a value of 30 cents. $1.30 and 30 cents would be $1.60. And that's what they told us it was equal to. So hopefully this makes sense as an example of how we could use decimals and problem solving to solve something we might be interested in. So let's review some of the key concepts here. Part A is about an example that we didn't do, but the concept is important. So we can always, if we have a question like this, we can always, instead of dividing both sides by the coefficient, we could, if we wanted, we could multiply both sides by something in order to not have a decimal anymore. So since this is in the tenths place, if I multiply both sides by 10, then 10 times 5 tenths is 5, and 6 times 10 is 60. So I could then solve it this way. So I still have to divide both sides by the coefficient of x at some point, but I can clear the fractions, or clear the decimals, is what it's called, by multiplying by whatever the place value of the decimal is. In this case, if it's in the tenths, we multiply by 10. If it's in the hundredths, we multiply by 100, and that's what that question is getting at. So let's look at B. Repeat example 1. We'll multiply both sides of the original equation by 10 as your first step. Does your answer match the example shown in example 1? Well, that's basically what we did here. So we multiplied by 10. So instead of doing that, let's solve by dividing both sides by the coefficient. Let's do in reverse what they're saying. So here you get x equals, what's 6 divided by 5 tenths? Let's see. I can't divide 5 tenths into 6, but I can divide 5 into 60. So that's the equivalent problem that I'm going to do. 5 goes into 6 one time, with 1 left over. Bring down my 0. 5 goes into 10 twice, evenly. So I can get the same answer both ways. And that's what A and B are trying to get at. Okay, let's look at C. If X is the number of nickels in a cash register, how can we represent the value of those nickels? The value of those nickels, if X is the number of nickels, the value of those nickels is 0.05 times the number of nickels. All right, let's look at D. If it costs 45 cents a minute to talk on your cell phone, write an expression representing the charge for talking X minutes. It's 45 cents per minute. So then 45 cents times X would be an expression for the price for talking X minutes. So hopefully that makes sense, how we're using decimals to expand what we can do with problem solving, especially in real world applications. And that's the basics of chapter 5, and we'll see you in the next chapter.